Okay, so now let us get to the section 5.8, okay, the integration using tables. Now you will see that to this section right here, we may have some integral is actually it's really hard to do the integrations, okay? So then in this case, in the back of your textbook, there's a table. This table right here will actually have some specified integram then for you to actually check it out and then get to, that's mean to help you to actually to solve those integrals then, okay? So where you could find the tables, if you have the textbook, basically is in the back of your textbook. If you don't have it, then I have it on Warmap, so it's under the keys for handout. Okay, so again, let me show you where you could find it. Okay, so you log it into Warmap, and then once you scroll down, okay, and then until you see keys for handout, okay, then under the integral tables, okay, so then you click on it, and then you should be able to see the table then. Now, if you look at our first example is related to e to the 2 theta, psi of 3 theta. Then now what you need to do is basically you are looking for the form, okay? So, and then you will see that under 98, then you have this form right here, okay? It's exponential and log. So, and number 98 is the one that we are looking for, okay? Okay, so let us go back to the problem now. Let's see how do we actually use a table. You will see that to this problem right here, you could check it out that compared to the 98, then you will find out that A is actually equal to 2, and then B is equal to 3, right? What you need to do is basically you just need to plug it in, okay? So therefore, again, to this one, the answer that you have, it will be e to the 2 theta over 2 square plus 3 square multiplied to 2 times psi of 3 theta minus 3 times cosine of 3 theta plus c. Okay, that's it. Okay, of course, you should simplify your answer, right? E to the 2 theta over 13, 2 times sine of 2 theta minus 3 times cosine of 3 theta plus c. Okay, yeah, that's it, right? Okay. Okay, now of course, some problem is not that easy. For example, like our next example, okay. Now the example that I have is, I would like to integrate the square root of 2y squared minus 3 over y squared, okay. When I look at the table, then number 42 is, seem that is really similar to what we have here, okay. Then now, think about this. What should I let u equal to, okay. In this case right here, I think that I would like to let u is equal to square root of 2y, okay? Because in this case, the u square is equal to 2y to the square then, right? So if this is the case, then of course we will have du will be square root of 2 dy, okay? But be careful about this, okay? In the denominator, I only have y squared. So therefore, in this case, make sure that you know that y equal to u over root 2. Okay, so just be careful about this. And of course, in this case, then what is a now? So I have, again, a will be square root of 3, right? Okay. Anyway, or probably we just need to use a square is equal to 3 here. Okay. Okay, so then now, if we understand this, then what we need to do is maybe let us work on this problem. Okay, so let me do with the substitution first. So I will have u squared minus a squared. Oh, maybe I would like to make this is a 3. And then this one will be u over square root of 2 to the square, and then the u over square root of 2. Okay. So then now what we could do here is we could actually work it out to simplify this. Okay, so I will have square root of u squared over 3 over u squared, and then this one will be 2 over root 2, and then du in this case. Okay, then now, after we have this, then what we could do here is, you will see that what happened, this form right here is exactly look like the left-hand side of 42 now. Then we could actually just plug it in, okay? So of course, we know that 2 over root 2, if we multiply top and bottom, basically it will be root 2, right? Okay, so then now I will have root 2, and then multiply the negative square root of u squared minus 3 over u plus natural log of u plus square root of u squared minus 3 plus c. Okay. And then now what we need to do is we just need to put it back the u in this case then. Okay, then I will have negative square root of 2y squared minus 3 over root 2y plus natural log of root 2y plus square root of 2y squared minus 3 plus c. And of course, I could simplify this a little bit more. Then I multiply the root 2. Then I will have negative square root of 2y squared minus 3 over y plus root 2 natural log of y plus square root of 2y squared minus 3. Okay. Let's see. So basically, again, just remember to simplify your answer. Okay, then now the next one is actually the secant square theta tangent square theta over square root of 9 minus tangent square theta d theta. Okay. Now to this one thing about this is what I'm looking for here is, wow, we have a lot of trick. Then probably we may, this actually give me a hint to how to find let's remove the table then. Of course, we have to work with substitutions, okay? So in this case, what I would like to do here is, I would like to let u is equal to tangent theta now, okay? The reason is the derivative of tangent is secant theta tangent theta d theta, okay? Then now you will see that what happened to this one right here. Okay, it seems that we have this become u squared, and then the other will be the u squared on the top then. Okay, so then now let's check this out. How do we actually work out this problem now? Okay. Ooh. Wow, I cannot take the derivative, huh? So the derivative of tangent theta, it will be secant square theta d theta. Okay. Okay, so let's see how do we actually work out the substitutions. Then, in this case right here, we know that this one with this is du, and then u is a tangent. So I will have this one is u squared du over square root of 3 squared minus u squared. Okay. Then right away you will see that a basically is equal to 3. Okay. And now what we need to do is we just use this table to help us to finish this. So it will be negative u over 2 square root of 9 minus u squared plus 9 over 2 sine inverse of u over 3 plus c. Okay. And of course, I'm going to finish this, which is equal to negative 1/2 tangent of theta square root 9 minus tangent square theta plus 9 over 2 sine inverse of tangent of theta over 3 plus c. Okay. Okay, so then let us look at the last one. Okay. So to this one right here, what do you want to let u equal to now? So I would like to let u equal to 2x. And then once I have this, then I have du equal to 2 dx. Okay. And remember, in this case right here, we also have x is equal to u over 2. Okay. Okay, then now what we would like to do here is I would like to work it out with this one. Then here, if x is equal to 2, then u is equal to 4. If x is equal to 3, u is equal to 6. So then I integrate between 4 and 6. Remember, this is u equal to now, right? This one is x equal to. And plug it in. So dx is du over 2. And then x is u over 2 to the square root of, this one would be u squared minus a squared, which is, okay. Maybe in this case, I don't need to work with a, so just 7 now. Okay, then now what we need to do here is, let us simplify this. So I have, this is 1/2, this is 1/4, so I could take out the 1/8. Mm-hmm. One half over 1/4, and then to this one is du over u square root of u square minus 7. Okay, then this is 4 to 6. So then now I will have 1/2 times 4. I could work it out this. So I apply the 45 now. So I will have a square root of u square minus 7. Okay. And then we will integrate between 4 and 6. Okay. And now I will have 2 times square root of 6 squared minus 7 over 7 times 6 minus 4 squared minus 7 over 7 times 4. Okay. now is an algebra now. So I have square root of 29 over 42 minus 28 square root of 16 minus 7. Okay. Okay, and then now I will have a square root of 29 over 21 minus 3 over 14. Or if you want to make it become only one term, then you could multiply this by 2, this one by 3. So, or it is equal to 2 square root of 29 minus 9 over 42. Okay, so again, it is your choice that you have this one or okay. So then again, one thing is make sure that you simplify your answer. Okay. Okay, so then that is it for this section. Of course, I only choose 4 examples, but again, basically, I just want to introduce how you could use a table to actually to help you to solve some of the integral. Okay, okay, thank you.